Hi ladies, this is lesson 3.5. It's about basic matrix operations. So matrices, we haven't really worked with these before, but we're using the same basic properties that we looked at in chapter 1. So just a few definitions to begin with. The first term that we have is matrix. And definition of matrix that we're going to use is a rectangular arrangement of numbers. In rows and columns. Now, something that's really key for this lesson is that rows go up and down and columns go across. So here is a row. Row, row, row. So there are 3 rows. So if you count from up and down, 1 row, 2 row, 3 row. Columns go across. So here's 1 column, here's another column, here's a 3rd column. So going across, you have 1, 2, 3 columns. The next term, dimensions. Dimensions are, you'll see them in terms of M and N. So M rows and N columns. So you read this M by N. That's how it'll be printed. So you'll say M by N. The next term, elements. The elements of a matrix are the numbers in the matrix. If you have equal matrices, that means the dimensions are the same. So corresponding elements and corresponding positions are equal. So two equal matrices first have to have the same dimensions, and then in row 1, column 1, for example, the value is 2. Row 2, column 1, the value for both matrices is 4. Okay, so the corresponding position elements in the corresponding positions are also equal. The next term, scale. A scalar is a real number. We'll use scalar for multiplication, but it's just a number. It's not a matrix, it's just a number. And then scalar multiplication is a real number used to multiply each element in the matrix. Okay, so pause as you need to copy down the rest of these definitions. But on your note sheet, so a matrix is a rectangular arrangement of numbers in rows and columns. So again, here's 4 rows, and here are 3 columns. So the element in the first row and 3rd column is 5. First row, top row, 3rd column, 1, 2, 3. That value is 5. Now, if you look at your note sheet, you see this adding and subtracting matrices key concept. So when we're adding and subtracting key matrices, we have to have the same dimensions. So you can only add or subtract matrices if they have the same dimensions. So, for example, this first matrix the dimensions of this first matrix are 2 rows, 2 columns. 2 rows, 2 columns, and our sum matrix is 2 rows, 2 columns. Same with subtracting, they have to have the same dimensions, 2 rows, 2 columns, 2 rows, 2 columns, and the difference matrix here, 2 rows, 2 columns. So to add matrices, we need to add the elements in corresponding positions. So A plus E, the first row, first column, gives us the first row, first column of our new matrix. B plus F, first row, second column, gives us first row, second column. C plus G, that's our second row, first column, gives us our second row, first column. C plus G. And then lastly, our second row, second column, D plus H, gives us our second row, second column, D plus H. Okay, so that's the same with subtraction. Add these two together. Add these two together. C and G, or subtract rather, and then D and H. Okay, so corresponding elements in corresponding positions. So let's try a couple. It says perform the indicated operation if possible. So remember, you have to have the same dimensions if you're going to add or subtract. So first, this has 2 rows, 2 columns, and this has 2 rows, 1 column. So we cannot subtract these matrices. That is specific to adding and subtracting. We'll next lesson talk about multiplying matrices, but specific to adding and subtraction, you have to have the same dimensions. Okay, the second one, we have 3 rows, 2 columns. 3 rows, 2 columns. So they have the same dimensions, so we can add these together, and we're going to get a matrix that has 3 rows, 2 columns. So let's do this together. So here are our matrix brackets. So we're going to add -2 plus 1, and that is the first row, first column of both of our matrices. Then we can add 1 and -4. 1 plus -4 is -3. That's our second column, first row. 0 plus -2. This is our second row, first column. Gives us -2. And our second row, second column, 3 plus 9 is 12. Our third row, first column, 7 plus 1 is 8. And then our second row, or third row, second column, 6 plus 5 is 11. So those two matrices added together gives us this new matrix, which is also 3 rows by 2 columns. So try this next one on your own and pause the video while you work, and you can unpause for the solution. Okay, so we're going to do the same thing. We're going to subtract now corresponding elements in corresponding positions. So we have a 2 by 2 matrix and a 2 by 2 matrix. So we can subtract these, and we're going to get another 2 by 2 matrix. So -6 minus 3 is -9. 2 minus 0 is 2. -1 minus 7 is -8. And -5 minus 1 is -4. Okay, so that was adding and subtracting, but now we're going to look at multiplying matrix by a scalar. And remember, scalar, that's any real number. So it's not a matrix, it's just a number. So think of this matrix as a group. So just like you would with the distributive property, if you had 3 plus 2, or actually let's use variables because it's a little bit easier. Okay, so x plus y as your group, you wanted to multiply that and that by 3. You would multiply each term by 3, so that's 3x plus 3y. Matrices are the same. If you're multiplying a matrix by a scalar, you're multiplying each element by that scalar. So it doesn't matter what your dimensions are for this matrix, because you're going to multiply each element in the matrix by that scalar. So if you have, like we do here, a 2 by 3 matrix, our product is going to be another 2 by 3 matrix. Okay, so let's multiply each element in our matrix by that scalar. 3 times 0 is 0. 3 times 2 is 6. 3 times -7 is -21. We're going to do the same thing with the second row. 3 times -1, 3 times 6, and 3 times 4. So our new matrix has the same dimensions. Okay, and you can do letter B on your own. So pause the video while you work, and you can unpause for the solution. So here is our scalar. Here's our matrix. It's 2 by 2. So our new matrix is going to be the same. It's also going to be a 2 by 2 matrix. So -2 times 1 is -2. -2 times 0 is 0. -2 times 3 is -6. And -2 times -5 is 10. So scalar multiplication is just like using the distributive property. You have to multiply each element in the matrix by that scalar. On your note sheet, just make sure that you can see what these properties should look like with matrices. So they're the same ideas as with real numbers. So the associative property of addition, I just am a little worried because sometimes it prints out weird on your note sheet, but it should say the group A plus B plus C equals A plus the group B plus C. That's the associative property. Commutative property should say A plus B equals B plus A. Distributive property of addition, K, which is your scalar, times the group A plus B equals K times A plus K times B. And distributive property of subtraction, K, which again is your scalar, times the group A minus B equals KA minus KB. So this next example is a word problem. And you can use matrices to solve these kinds of problems. So it says that we have 2 pet stores that sell both cats and dogs. Sales from each store for last month and this month are shown below. So it says last month, store 1 sold 42 dogs, 33 cats. Store 2 sold 56 dogs and 21 cats. And then it has data for this month too. So it says to organize the data into matrices. Then write and interpret a matrix giving the average monthly sales. So that tells us we're looking for average monthly sales. So that tells us that we're going to have 2 matrices. One is going to be month 1, last month. And one matrix is going to be this month. Okay, so let's organize this into matrices. It says organize the data into 2 by 2 matrices. Okay, so this first one is last month. And the second one is going to be this one. So in last month, we have 2 stores. We have store 1 and store 2. And we also have 2 stores for this month. Store 1 and store 2. Okay, and then we also have dogs and cats. Okay, so last month our rows, last month and this month, our rows are our store numbers and our columns are our animals. So last month, store 1, they're dogs. So store 1, dog, that's our first row, first column. We had 42. Store 2 had 56 dogs. Store 1 had 33 cats. Store 2 had 21 cats. This month, store 1 had 36 dogs and 51 cats. And store 2 had 48 dogs and 37 cats. Okay, so now it asks us average monthly sales. So how do we find average? Let's call this, just so we can see, let's call this matrix A, and let's call this matrix B. So to find average, we're going to add A plus B and divide by 2, which is the same as multiplying by 1/2. Okay, so here's what we're going to do to find the average monthly sales. Grab our matrices. Now let's add those 2 together. So our first matrix plus our second matrix added together, and we'll do 1/2 of this still. So we're using order of operation, so we do what's in parentheses first. So 42 plus 36, 78. 33 plus 51 is 84. 56 plus 48 is 104. And then 21 plus 37 is 58. So we added our 2 matrices together, and now we need to multiply by the scalar, which is the same as dividing by 2, multiplying by 1/2. So our average monthly sales, we can put this in the form of a matrix. So we get 39, 42, 104, and, oops, that was our, we need to divide that by 2. So we get 52 and 29. So that says for, this is store 1, this is store 2, this is dogs, and this is cats. So our average monthly sales for store 1 for dogs is 39. Average monthly sales for store 2 for dogs is 52. Average monthly sales for store 1 for cats is 42. Average monthly sales for store 2 for cats is 29. All right, our next example then, example number 4, is to solve the matrix equation for x and y. So again, you're going to have to consider your order of operations. So if 4 times the matrix groups, the first matrix, again, we're just going to call this A, and we'll just call this B, just for now. We're going to add A and B together first, and then that sum matrix, we're going to multiply by 4. Okay, so first let's add those 2 matrices together. So 3x plus 1 and then 1 minus 3 and then 0 plus 2, which is 2, and then 6 plus a negative 2y, which is 6 minus 2y. When you write your matrices out, make sure to use very distinct columns. Your rows should be pretty easy, to just make sure you line them up, but your columns, you want to use like the first number in each column. Or, sorry, you just want to make sure that your columns are distinct. Okay, so this is clearly column 1, and this is clearly column 2. You're not confusing any numbers for being in a different column. So just make sure that that's very clear when you write out your matrices so that you don't confuse yourself. Okay, now the next step, if we evaluated this by the scalar of 4, we would multiply 4 times the first element. So that's like 4 times the group, 3x plus 1. So that gives us 12x plus 4. And then 4 times the element in the second column first row. So 4 times negative 2, which is negative 8. 4 times 2 for our second row first column. And then 4 times the group 6 minus 2y. So 4 times 6 is 24 minus 4 times 2y, which is 8y. Okay, now we know that this matrix equals this matrix, okay, because 4 times the sum of those two matrices equals negative 8, negative 8, 8, 0. Okay, so now each element has to correspond to the element in the next matrix. So So 12x plus 4 is equal to negative 8. 8 is equal to 8. Negative 8 is equal to negative 8. And 24 minus 8y is equal to 0. So now if you're actually solving for x and y, which is what it is asking us to do, we could say 12x plus 4 equals negative 8. So now we can solve for x. So that gives us 12x equals, we're subtracting 4 from both sides, negative 12. Isolate our variable by dividing both sides by 12, and we get x equals negative 1. And then we're going to do the same thing with our y variable. So 24 minus 8y equals 0. So 24 equals 8y. We add 8y to both sides. And solve for y by dividing both sides by 8. We get y equals 3. Now to double check, you can plug those values back into your original matrix and do that and do those operations again. Just to double check your answer. So again, just like we did last lesson, I would always encourage you to double check your answers, but you should get x equals negative 1 and y equals 3. Okay, so please jot down any questions you have on this, and we can go over it next time I see you in class. Thanks, ladies.